Hello Methods students, and welcome to our first lesson on derivatives and differentiation. So in this section, which I guess the broader section we call calculus, we're really concerned with different techniques for finding the rate of change or for finding the gradient either between 2 points on a curve or at an exact point on a curve. We're going to start off with looking at the average rate of change, which is actually where we take a function, we take a curve, and we try to work out the average rate of change between 2 points on that curve, which is actually something that you'll be pretty used to from previous years, because it's really just doing a rise over run calculation. You can see here we've got this rule that says the average rate of change is equal to y2 minus y1, there's your rise, over x2 minus x1, and there's your run. So really we're just doing rise over run calculations anytime we're asked to find an average rate of change. So in example 1, we're asked to determine the average rate of change of the function f of x equals 2x squared minus 3 between x equals 0 and x equals 3. So let's get straight into the rise over run. We already have the values of x1 and x2. What we don't have yet are the y values to work out the rise. So we're going to work out the y value when x equals 0 and work out the y value when x equals 3 in order to get those y values. So let's do that. So let's say we're going to work out f of 0, right? And that will just be obviously 2 times 0 squared minus 3, and that will just be negative 3. Then we've got to work out f of 3. So that'll be 2 times 3 squared minus 3, which will be 2 times 9, so 18. 18 minus 3, that'll give us 15. And so our average rate of change is going to be equal to, well, y2, the second y value, minus the first y value, over x2 minus x1, the first x value. Okay, so I guess more formally you could think of it as f of 3 minus f of 0 over 3 minus 0. So that just gives us positive 18 over 3, which of course is 6. So the average rate of change, or the gradient between those 2 points on the curve, is equal to 6. Now, there was no requirement to draw a picture or anything for this question, but it might be good to think about what's going on by having a quick look at a bit of a rough sketch. So if we think about the function that we drew, well, 2x squared minus 3, we should be able to look at that pretty quickly and recognize it'll be a positive parabola. There's no horizontal shift, but there is a vertical shift down 3 units. So the turning point would be down at, let's say, this is about negative 3. And the parabola is going to be doing something like, I've made that a little bit pointy. We're doing something like that. Right, now, what we were asked to find was the rate of change of the function between x equals 0 and x equals 3. So we're using this point here when x equals 0. A little bit of quick sort of calculating will tell you that intercept is before 3. So when x is equal to 3, we're sort of somewhere, roughly over here. And what we've just done is found the gradient between those 2 points. Okay, so if I try to use a ruler to actually make that a bit clearer, otherwise I'll make a mess of it. We're really calculating the gradient of that line there that passes through these 2 points. Okay, and the coordinates we got from that were 0, negative 3, and 3, 15, and that's what we used to do the rise over run calculation. Again, wasn't necessary to draw the graph, but it's good to understand what's going on and also see why we got a relatively large positive gradient, because you can see even just from that rough sketch that we've got a line that's pretty steep. So I hope that explains how to find the average rate of change between 2 points on a function. Good luck with your questions, and we'll see you in the next video.